So this topic of right angle triangles has two sections to it. The first section is one that you've done before, which is Pythagoras' theorem. That's what we're starting with now. We'll do a few lessons on that, and then we go into a completely new thing, which is trigonometry. You've probably seen the buttons on your calculator with the sine, cos, and tan. You'll be learning about those finally. Okay, but familiar territory first, Pythagoras' theorem. So there's some history there. Pythagoras' theorem is one of the oldest and most commonly known mathematical relationships. It only applies to right angle triangles. The longest side of a triangle is called the hypotenuse, that lovely word there. And the other two sides are sometimes called the legs, although I usually call them the arms. But legs or arms, they're the two things that are coming out from the right angle, and they are the A and the B in the formula that I'm going to be giving you. Okay, so just to practice, in these first few triangles that you see here, it says name the sides on the following triangles. So the first thing I want you to do is I want you to find that hypotenuse. To find the hypotenuse, you look for your right angle. Here's the right angle. And the hypotenuse is the one straight across from that. Now I'm just going to call it H. H for hypotenuse. The two little sides, the ones that are attached to the right angle, so these ones here, that's the A and the B. It doesn't really matter which one is which. Okay, so I'm just going to go A here, B there. Right? Can you try triangle 2? See if you can label the H and the A and the B. 10-second job. Did you do it? Yep. All right, so you should have the H here, and the A and the B are those two, but it doesn't matter which one's which. If you do it the other way around, it's still right. Yes? Okay, good. Now, Pythagoras' theorem, this is more history, was discovered by a man named Pythagoras. And what he did was he discovered the relationship between the three sides of the triangle. And this is kind of what he did. What we're going to do, because I know you don't all have rulers, we might just do this not to scale. We want to draw a square off each of the sides that are there. Now, if you had a ruler, does anyone actually have a ruler? No? That's all right. This side here measures 3 centimetres. This side here measures 4 centimetres. And this side here measures 5 centimetres. Okay? If you draw a square that comes out on that side, so it's 3 centimetres long and 3 centimetres wide, so it's, how do you find the area of a square? Does anyone remember? You times the side by itself. So if the side length is 3 centimetres, it's 3 times 3, which is 9 centimetres squared. All right, let's do that on the other sides. If I do a square for the 4, so it's a bigger square, what's 4 times 4? Do we need the calculators? 16, so this one's 16 centimetres squared. And the last one, which is a bit of a tricky one to draw because it's a slopey square. What is 5 times 5?
25.
Yeah. All right, now what Pythagoras noticed was when you do these weird squares going around your triangle, when you add 9 and 16 together. Let's go. 9 plus 16 equals 25, which was the third side. So that's what he found. For every single right angle triangle, that is 2 shorter ones squared and added together gives you the longer side. So this is Homer Simpson thinking, do any of you guys even watch The Simpsons anymore?
I've seen like some.
Anyway, you've seen it, anyway. He thought he was smart because he could do Pythagoras' theorem, but anyway. This is the formula. That is the traditional Pythagoras' theorem formula. So we have our hypotenuse here, our A and our B on our 2 arms, and this is the formula. If I square the 2 shorter ones and add them together, then I will get the hypotenuse. But I don't want you to memorize or use that formula. Instead, I'm going to get you to rearrange it. But before we do, here is some more practice. It just says to label the hypotenuse on each of the following triangles, just the hypotenuse. That's the most important one that you can identify. So grab a pen and across from the right angle, put a H. Uppercase H or lowercase H, it doesn't matter. I just used capital because it was cap on the question. So capital H, cross from the right angle. See if you can fill them all in. Done already. It's too easy. How about the rest of you? Yeah? As quick as that? Did you get them all? Alright, good. Just very important that we know how to do that. Okay, so we are going to start with just finding the hypotenuse today. So instead of the other formula that was h squared equals a squared plus b squared, because I want to find the hypotenuse, I don't really want this squared there. Okay, so to get rid of a squared, the opposite is to square root. So I can get rid of this squared here if I square root that side. And so this is the formula that I want you to memorize. This is the one that you are always going to use if you are trying to find a hypotenuse. Okay, so this one is going to go on our study sheet later today. All right? So when you see a question like these ones here, the first thing you'll see, right angle triangle is very, very important. And the thing that we're trying to find is the hypotenuse. Okay, so as soon as you identify that, you go, all right, I need my hypotenuse formula, which is h equals square root of a squared plus b squared. There's going to be 3 lines of working out that I want you to do for each question. The first one's the formula. The second part of the working out, the second line, is to sub in the numbers that were given on the question. So the A and the B, remember, are these 2 arms. Doesn't matter which one's which, the 6 and the 8. Okay? I'm going to sub them into that formula. The A, I have labelled the 6, so that's going to be 6 squared. And what was the B?
B squared.
What number is it? 8. Yeah, 8 squared. So there's my second line. The third line is we get our calculator. Come on, calculator, there it is. And we type it in. So square root button is here. So everyone type this in, square root. And then I want 6, and you need a little square button, which is that one there, the X with the little 2 on it. 6 squared plus 8 squared, and press equals. Did you all get the same as me? Did you all get 10? Yeah. Beautiful. So the answer is 10. And this one, because we know that this was centimetres, my answer is also going to be in centimetres. So put that on there. Some of the questions in your exercise, there aren't any units, so you just leave it blank. But if they tell you centimetres, you should include it. All right, let's do it again. Second question. We're finding the hypotenuse, so we're going to write our formula down. Formula, h equals big square root a squared plus b squared. Second line we're going to sub in. I'm going to call the a the 9 and the b the 12. Now, you will notice that there's a different letter over here on the hypotenuse. So I could call this x equals instead of h equals for my second line, but if you kept that as h, you're still going to be fine. All right, I'm fine with that. Let's sub in. A is 9. 9 squared plus b, which is 12. So 12 squared. Third what line? Type it in your calculator. So square root. You've done it already. Well done. Yeah, 15. 15. And what's the units this time?
Meters.
Meters. Perfect. Okay, let's do some more. So all of these ones are going to be finding the hypotenuse. So let's go. H for hypotenuse equals square root a squared plus b squared. Okay. A is going to be the 2.5 and b is going to be the 6. Let's sub it in on the second line. And because there's a k there, we can say k instead of h. Square root 2.5 squared plus 6 squared equals, and in the calculator, 6.5 millimeters. Question 4 has an extra little twist. Can anyone see something that might cause us a little problem with question 4? Perfect. Yeah. Different units. You can't have one of them in centimetres and one of them in millimetres and put them in the formula. So you have to make them the same first. If the question doesn't tell you which one to use, it doesn't matter. You could change to centimetres or millimetres, but you just have to be consistent. What do you want to do? Centimetres or millimetres? About the same. Centimetres. Destiny says centimetres. What did you say? Centimetres. Oh, good. All right. So that means that this one is fine because that one's already in centimetres. But how do you change 80 millimetres into centimetres? Divide by 10. Who said that? Good job. Divided by 10. What is 80 divided by 10? 8. So that is just 8 centimetres. You can put a little divide by 10 there if you need a reminder on how we got that.
Is it always divided by 10?
If it's centimetres and millimetres, yes. But if it was metres and centimetres, it would be 100. Depends on the... There won't be a lot of these converting ones yet. This is kind of like an extra step. All right, let's put our formula down. H equals square root a squared plus b squared. The a is the 7, so it's going to be 7 squared plus 8 squared. Am I going too fast? Third line, type it in. We might get a decimal answer for this one. 7 squared plus 8 squared equals, look at that. Okay, so let's just have a sneak peek in your booklet on an exercise. When you do it, on the next page it says 1 decimal place. So let's do 1 decimal place for this. So at decimal point, the 1 decimal place is the 6. The 3 tells me whether I round up or down. So it's a 3, am I going to round up or down? The 3's round up or down? Down. Anything 5, below 5 rounds down, anything 5 and up rounds up. So we used to call this, a long time ago, the critical digit because it tells you how to round. Because it is lower, it's just going to chop off the decimal places there and it will just be 10.6. If it was going to round up, then it would become 10.7, but not for this one, okay? So we want 10.6. 10.6, and this was in centimetres. Yeah? Okay, so that is the end of my explain part, and now you get to practice it over and over and over again. So it all follows in the booklet.